Virtual Extensible Local Area Network, otherwise called Vxlan, is a tunneling protocol. It's an encapsulation method similar to GRE tunnels, and it tunnels Ethernet layer 2 traffic over an IP, which is a layer 3 network. Now, with traditional layer 2 networks, they have a couple of issues like spanning tree, which blocks redundant links to avoid loops, which means that you're basically paying for unused links. Has a limited amount of VLANs, so we could use like 4,094 VLANs, and if you're a service provider that has 1,000 customers, that means that they can only offer 4 VLANs to each customer. And also you have like large MAC address tables. Now, before virtualization, a switch only had to learn 1 MAC address per switch port. But nowadays we run many virtual machines where each VM has a virtual MAC address, and the switch has to learn lots of MAC addresses for each single switch port. This means that each switch has to store the MAC addresses of all the VMs that communicate with each other, which requires much larger MAC address tables compared to networks without virtualization. Now, Vxlan uses an overlay and an underlay network. An overlay network is a virtual network that runs on top of a physical underlay network. We have to realize that unlike with traditional networks, where we would have a physical trunk link between switches, nowadays in data centers, we have like a spine and leaf architecture, and Vxlan will be running tunnels between the desired switches. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and yeah, subscribe. Okay, back to the video. With Vxlan, the overlay is a layer 2 Ethernet network, whereas the underlay network is a layer 3 IP transport network using protocols like EIGRP, OSPF, and ISIS. The only purpose of the layer 3 underlay network is to get traffic from A to B. These two networks work independently of each other, and changes in the overlay won't affect the underlay, and as long as the underlay has a route from point A to point B, the overlay will be operational. You could also use BGP if you wanted as a routing protocol for the underlay network. Then you have the VNI, which is the Vxlan Network Identifier. And this identifies the Vxlan and is similar to a VLAN ID. There are 24 bits in a VNI, which gives us 16 million Vxlans compared to 4,094 VLANs. The valid VNI values are from 4,096 to 16,777,215. It's through these VNIs that the end host will be able to communicate. And this concept is exactly the same as assigning an end host to a VLAN. Then you have the VTEP, which is the Vxlan Tunnel Endpoint. And that is the device that's responsible for encapsulating and de-encapsulating layer 2 traffic. This device is the connection between the overlay and the underlay network. And there are 2 types of VTEP. There's like a hardware VTEP, which is like switches and routers. And then you have a software VTEP, which can be found in servers and hypervisors. You have your NVE, which is your network virtualization endpoint. Each Vxlan switch has a VTEP virtual interface called an NVE, and the NVE gets a /32 IP address from a loopback interface, and with Vxlan it's always a loopback interface, and this is in turn advertising to the IGP. The NVE then has 1 or more VNIs bound to it. This is how the VTEP gets access to the LAN segments in the overlay. We've now explored the terminology. Let's now get into the process of how Vxlan actually operates. In a Vxlan network, hosts communicate with each other by first querying their MAC address tables. So here, host will want to communicate with host 2. This means that the VTEP needs to learn the MAC address of host 2. However, here's where we come across a problem. The original Vxlan doesn't have a control plane defined as a standard, so any learned host MAC addresses cannot be transmitted between VTEPs. Also, Vxlan must be able to deal with BUM traffic, which is broadcast unknown, unicast, and multicast traffic. In more complex environments, multicast is used. VTEPs forward traffic through flooding like traditional Ethernet switches, but in our case here with Vxlan, each VNI is mapped to a multicast group, and when a VTEP comes online, it joins the multicast group for the VNIs that it has. Any VTEP that is part of that group will receive the BUM traffic once the original VTEP floods it to that particular multicast group. However, some organizations don't want to run multicasting in their core, so how are they going to take advantage of the Vxlan? The answer is they will use static ingress replication. This is where remote peers are statically configured and packets are encapsulated and delivered to each of the statically configured remote peers. So we've come on to the lab portion of Vxlan, And I will probably break this down into two sections. So the first section will be basic VXLAN. We will use the ingress replication just to do static peerings across to our VTEP peers. And then we'll go on to a more advanced one where we might use VPCs on one end or on both ends maybe. We'll use multicast as the control plane protocol. We might have multiple VNIs between the VTEPs. And we'll see when we come on to the more advanced VXLAN configuration. But for the time being, this is the topology that we're going to be working with. So we've got two VTEPs here, VTEP 1 and VTEP 2 in a spine and leaf configuration. And we've got host A connected to VTEP 1 and host B connected to VTEP 2. And I've got those open here. So they've got no real configuration on them. All I've done is the base configuration where I've changed the username and password and added the switch name, and then I've saved that configuration. And the first thing that we have to do, we're going to be using OSPF as our underlay protocol. So we need to enable the OSPF feature. So the first thing we do is feature OSPF. The next thing that we have to do, we have to use something called the VN segment VLAN based. And this allows us to map the VLANs to the VNIs, which are the VXLAN identifiers. And you have to remember to have a valid VNI. So we use like numbers from 4096 to 16 million. And this is feature VN segment VLAN based. And the last feature that I'm going to enable here is the NV overlay, which enables the VXLAN feature itself. Feature NV overlay. Another thing that I will do is, because the VXLAN header size is like 8 bits, and then you have like a traditional MTU size of 1500, and then you got like 14 bytes for the Ethernet header. And because VXLAN is called L2 over UDP, there's an additional 8-byte UDP header. And I'm sure there's extra stuff in there as well. Yeah, there's also another 8 bytes for the IP header. So this is like 1570 or something like that. Now, I've never seen it like that in the real world. I've always seen VXLAN being used with like jumbo sized MTUs of 9000. So we're going to do that here. And I think the command is something like system jumbo MTU of 9000. And that's what we're going to be doing. So we've got to remember those 4 things. We do feature OSPF to enable OSPF, your VN segment, which allows us to map the VLANs to the VXLAN, your NV overlay to enable VXLAN, and then your system jumbo MTU. And we're going to do that on both sides. So feature OSPF, then feature VN something, and then feature NV overlay, and then the last one is system jumbo MTU 9000. And let's just save that on both sides. I've changed Macs and I've changed terminal programs, but we're going to continue on with the VXLAN configuration, and now we're going to move into configuring the actual underlay. This is our network, so we're going to start off by configuring the 2 cores, and then we're going to move on to configuring VTEP 1 and then VTEP 2. Now I have these sessions open, here they are. So we're going to start with configuring core 1. First thing that we've already got the feature enabled, so what I will do is router OSPF 1 just to enable OSPF. Then we'll go into the interfaces, interface E1/1, no switch port, and then we're going to do the IP addressing, IP address 10.1.13.3/24, and you configure the actual OSPF underneath the interface. So IP OSPF 1 area, everything's going to be in area 0. Okay, maybe the IP router? No, it is IP OSPF. Maybe the feature's not enabled here. So let's just do that. Feature OSPF. Alright, let's try this again. Interface E1/1, IP OSPF 1 area 0. IP router OSPF 1 area 0. Okay. And let's no shut that interface. And do the same for interface 2. This is going across the VTEP2, so IP address will be 10.1.23.3/24. No shut the interface. And that should be it for the core configuration. So let's save that config and move over to core 2. I don't think I need the no switch port command here because I think that they're all routed ports by default. Let's just check that. Show interface brief. Yeah, they are. Okay, so interface E1/1. This is going to VTEP2. So IP address is 10.1.24.4/24. IP router OSPF 1, which is area 0. No shut the interface, and then the same for interface 2. Then we're going to move on to configuring the VTEPs. This goes up to core 1. It's in area 0. No shut the interface. And then the one going across to core 2, which is E1/2. And then we need an additional interface here so that we could create an NVI interface. And we're going to use loopback 0. Just going to make it 1.1.1.1, and it has to be a /32. And we need to advertise that into our IGP, which is OSPF. Let's save that configuration. And then the same for VTEP2. So E1/1 goes up to core 2. So that is 24.2. And then we need our NVE interface, or it will be associated with the NVE interface on loopback 0. And let's save that. And that is it for our underlay. Our underlay configuration is complete. Let's just do some OSPF checks. Alright, so that looks good. Now we see that the uptimes has changed. That means I probably had already completed the OSPF configuration, but it's showing that the neighborship is up. Let's see if we can ping R1's loopback. Which we can. We have full reachability with our IGP. Let's now move on to the overlay configuration. So our underlay is complete. Now we're going to move into our overlay configuration. And we know that when we're associating our VNIs, we need to use a VNI number from 4096 up to 16 million plus. So the first thing we need to do is get a VLAN and associate our VNI with that. Now I'm going to use VLAN 101, and all this overlay configuration is done on the VTEPs. Our core devices are no longer involved. I'm going to say our VN segment is going to be 10,100. Then we're going to associate our interfaces that are going down to our end devices to this VLAN. Now let's just have a look. And we can see that our end device on VTEP 1 and also on VTEP 2 is E1/3. So let's associate that with our VLAN. Interface E1/3. Switch port. Mode is access. Okay. All right, so let me just make it a switch port first. So switch port, and then switch port mode is access. Switch port access for VLAN 101, and no shut that interface. Do that same configuration on VTEP 1. I haven't created the VLAN here, 1 second. VLAN 101, VN segment is 10,100, interface E1/3, Alright, now we need to create our NVE and associate our loopback address to this. So let's say interface NVE1. Let's make sure we no shut this interface. We're associating our VNI to this now. This is how our VTEPs get access to the other side. And this, now we need to make our ingress replication protocol. We're just going to do a static peering. And I think you only have the option of static or BGP. Yeah, so we're going to be using static here. And our peer IP address will be the loopback address of VTEP2, which is 2.2.2.2. Let me just save that and do the same on VTEP2. Ingress replicate, and our peer IP is 1.1.1.1. Let's copy that and let's see if everything is up. Let's have a look at our NVE interface. Well, it's showing that it's up, which is good. We can also run like show run interface NVE1. That's our configuration. Then we could say something like show NVE VNI. We can see that we're using unicast. This is our VNI. It is currently up at layer 2, which is superb. Let's say show NVE peer detail to see what our peer is saying. And our peer is up. It's been up for 3 minutes. It's using a VNI of 10,100. We could also look at the MAC address table, see if we're seeing the MAC address of the other side coming in. Show MAC address table. Well, we're seeing our Ethernet 1/3 coming in. So let's jump onto one of these end devices and see if we could ping the other side. Okay, so it doesn't look like there's been anything configured on the end host. So let's just do that quickly. And our interface is 0/0, G0/0. So interface G0/0. IP address should be 192.168.1.1 on this side. No, shut that. And on, let's just give it a name as well. Host name is called host A. And on the other side, host B. And these hosts have got no idea what's going on internally, so they just think on their side that it's a directly connected interface across VLAN 101. So do ping 192.168.1.1, repeat 100. Let's have a look. And there we go. We have reachability. So this is our basic VXLAN configuration. We've configured a VNI across a layer 3 infrastructure, and we can see that we have reachability. If I look onto VTEP2 now, I should see the MAC address coming in. Yeah, and we see the MAC address coming in, and we can see that it's coming across NVE1 with an address of 1.1.1.1. Okay, that's it for our basic VXLAN configuration. I'll see you in the next one.